Hi, my name is Damian Wylie. I have the privilege today to talk to you about Wherobots, but also I want to focus more of my time today on some of the problems you can solve with satellite imagery and doing this at scale. I lead product. I've been with Wherobots for about a year. I joined from Databricks, and prior to that I was with Amazon Web Services for roughly 9 years. And you'll see some similarities with Wherobots and Databricks, and I'll talk more about that in a minute. But what's this talk about? What I want to do is introduce you to Wherobots, because I don't think that's been formally done yet at this conference. Have been fielding a lot of questions as well about what Wherobots is and what we do. But ultimately what I want to get to is how you can use Wherobots to take your ideas that you have, specifically around satellite imagery and raster data, to produce solutions and value for your business or your mission. All right, so let's start with how Wherobots got started, and that's with Apache Sedona. So years ago, Mo and Gia, who are our co-founders, they were at Arizona State, studying some spatial. They were doing some spatial research, and they one of the problems they saw was that there wasn't great support in the broader ecosystem to perform very large-scale spatial analytics, and that's ultimately what was the reason that started Apache Sedona. Before this, it was actually called Geospark, but then its name transitioned to Apache Sedona. And it's quite popular. It's quite popular now, and it's grown in popularity. We're measuring the downloads per month, and you can see it's growing more than 2 million a month. And it's primarily used with Apache Spark, and it actually modifies Sparks and it provides it with a number of capabilities that allow you to process both raster and vector data at scale, including clustering. So like performing operations like dbScan, for example, if you're looking for hotspots or other clusters in your data. It's very popular, it's well supported, and it's also being used on a number of different platforms and used in production across a variety of companies. I'm listing them here. One notable one that we work closely with is the Amazon last mile delivery team. They're using Apache Sedona in their operations continuously. All right. So here's very high level, and if you guys want to go into the weeds on Wherobots and what we can do and capabilities, I'll do that after we got time at this event. But ultimately, what we want to do is drive innovation with solutions that are brought about in the physical world, but also intersect the digital world. What I mean by this is solutions that are typically otherwise constrained by scale. So these solutions are prevalent in climate tech, agri-tech, insurance, mobility, and automotive. Those are just a few. Government is another one. There's very large-scale problems that can be solved with geospatial data, and what we're on a mission to do is make that geospatial data easy for you to utilize so you can solve those problems. Within the Wherobots platform, I talked about Apache Sedona, so it's one of the things that we have at our core is compatibility with Apache Sedona. You can lift and shift your Sedona workloads into Wherobots with ease and out if you need to. We're also, one of the great things that our customers are calling out when they're using Wherobots is they're more productive. They're more productive because they can work across a variety of different types of data all in a single unified environment. You don't need to go from one system to the other and transfer data or pick up different tools. You can work with your structured data, your typical internet data. You can work with your vector data and also your raster data, and you can conflate those together, filter them to produce the end result that you're looking for. And this is we call this spatial intelligence. The other noteworthy point that I want to drive home is, while Sedona does provide optimized for Spark, optimize processing of spatial data, we've developed a number of techniques internally and driven, and I'll show you here in a minute, but the scale and performance that you can derive from using Wherobots is you'll see it's industry leading. And I'll have a slide on this in a minute. But it also delivers industry-leading price performance as well across different engines, specifically measured against like BigQuery, Snowflake, Databricks, and obviously open source, Apache Sedona as well. And then you've seen this theme probably in different sessions, is that Wherobots is involved in driving standards. One of the things that we've identified as a company is that the geospatial data has been siloed. And so solutions have been siloed as a result. We're bringing modern techniques, modern standards that you see in internet data, including Iceberg, Parquet, and then also in the model management space, there's a specification that we're behind, the MLM spec that I have a slide on, and there's actually a talk later today on it. And the goal here is to unlock your data so that it gives you flexibility to choose the solutions that are going to help drive your mission forward. So deploying, breaking out of those silos and getting into more of a cloud-native way to manage data gives you the capability to bring the best tool over time, rather than being forced into maybe a siloed solution that you have to work around. Ultimately, to summarize it all, this is very high level plan for how we're making geospatial data easy to utilize to drive your solutions forward. And increasingly, you see these types of events happening across our world. And this was a very sad event, and I apologize if you or your family was impacted by it. But this is just one example, including like LA fires, of there's geospatial data that can help us understand, not only prepare for these types of events, but also what happened. And these are very large scale events. So imagine analyzing, trying to figure out who was impacted by, using the data at hand, who was impacted by the hurricane, Hurricanes Helene and Milton. You're going to require, it's probably require a combination of what homes were there. Maybe you're an insurance company and you're trying to think about, okay, I've got these assets out in the field, and then there's satellite imagery that's telling me what was the damage that had occurred. And you might even have a path of the hurricane. How are you going to conflate all of those together to figure out the scope of impact? That's the type of problem that Wherobots is well suited to solve. Okay. So there is trillions of dollars invested in this physical world. Everyone knows that. And geospatial data is there to help you understand the risks around those assets, and what's happening around those investments as well. So these are just a couple of the types of industries that we're working with, the customers that we're working directly with, to help build modern solutions that are going to, change. Some companies are more capable of building new products and monetizing those products as a result of the technology we have. Others are they're bringing more scale and scope and lowering their costs as a result of our technology. And one thing that is increasingly happening is that there's more and more geospatial data that's available at your fingertips, including processed data. You've got products from Overture, for example. More and more geospatial data products are coming to the table, and what companies and organizations need is a way to make sense of all this data and to produce the solutions that are going to help drive them forward. Now, some of the challenges that you've probably faced working with geospatial data is that once you hit this outside of the scale of what a single VM can provide in terms of performance, it starts to slow down. You also see in engines, modern cloud engines, that spatial support is second rate. Look at name your cloud engine, BigQuery to Databricks to EMR, those engines were purpose-built to solve internet data problems. They weren't purpose-built to solve spatial problems. It takes a different type of engine to solve those problems. And then you also see there's solution silos that will lock you and your data in that will hamper your innovation. So I talked about performance. This slide is a price performance slide. So on the left column is benchmarks that we ran, and we're showing these benchmarks here. And you can see the queries specifically, but they're large scale benchmarks where we're joining postal codes along with buildings and OSM nodes, and then also buildings to OSM nodes. And you can see not only the performance in terms of time, how fast these queries ran, but also like relative cost compared to what you would see in another engine. Now, for the most part, you can see that like Wherobots is generally, up 1 to 20x better in price performance. Sometimes some queries just didn't even run on other platforms. The point that I want to drive home is what we've built is a purpose-built engine from the ground up designed for your spatial data, whether it's an S3 in the open, to process it and do it more performantly so that you can build new solutions and move your mission forward. Okay. And when the challenge you face this today is like if you're on some of these other platforms, you typically have to piece things together to figure out like how to solve a problem. Here's an example of a standard that we've been driving. This is the Apache. Gia had a great presentation today on this, but Iceberg and Parquet are now or will support geo types natively. And then we're also driving the MLM specification, which we'll talk about here in a minute. So in a nutshell, this is kind of what you get if you can summarize it in a single slide. What Wherobots provides. We currently run on AWS. We will be bringing our cloud services based on demand to Azure and Google Cloud. And we run on your data in your S3 bucket. We also connect to other data stores. We're not a data storage system. We are a computational solution for your data. All right, that's my, I guess, 5 or 10 minute summary of Wherobots. Okay, so let's talk about raster data. Raster data is a way to observe. Typically, it's captured by satellites or even drones. It is a data type that is used to capture what happened or what is happening on the ground. And typically, rasters are multi-band. You've got, you might have an RGB band, you might have a temperature band, et cetera. And so it's a very complex data type. And there's petabytes of this data available. I mean, you have satellite imagery that's widely available. It's free and open to use from various places. And now, how many of you worked with raster data? How many of you find it's easy to work with? Some? Okay. The experts are probably raising their hands. So what we found when talking with customers is that, first is those experts who raise their hands, probably their expertise is scarce, and then it takes a lot of expertise to go from data to insights reliably over time using satellite imagery, for example. It's also prohibitively expensive in terms of not only development time, but the inference platforms that are available today are not really designed for the scale of imagery that you're trying to jam through them. And then there's some undifferentiated overhead that you have to do to prepare the imagery. You can't just take it off the shelf. You're preparing mosaics, you're doing filtering and ETL work ahead of time before you can actually run those models that you're particularly interested in. So what we're doing with raster inference under the Wherobots AI product line is that our goal is to make solutions that you have a need for easily creatable and accessible from satellite imagery and run these continuously over time. So we're baking in expertise under the hood We've got a team of talented engineers that have had, a lot of expertise working with raster data and doing inference and running models, creating models, et cetera. And we're packaging those best practices in a product that you can just utilize, and I'll walk you through that here in a minute. It's optimized for raster ETL and computer vision. So those computer vision models like that are available on TorchGeo, for example, those models will be available in Wherobots soon. You can even bring those in today and then just run them on Wherobots without having to worry about any of the undifferentiated setup costs of what it takes to like get an inference platform running. And by the way, it's all on demand, so you just pay for the resources you use on demand. And you can easily create once you have the results. I mentioned that you can easily create like other. You can join those results with your other data you might have directly within a single unified environment. We're also working on how a capability to make it easy for you to create mosaics as well. But this is more forward-looking on our roadmap. So this is a very high-level diagram of how it works. On the left is a large-scale image. I believe this is in Arizona, and you take an image. We have a stack reader baked in. You've probably heard of stack. I won't get into it, but we can just directly reference stack, your stack collections within our platform, and only pull in the data that you need to run inference on. We're not transferring everything over the network, for example. You can run our models that we have off the shelf, and that collection is only going to grow over time. Or you can bring your own model in as well and run that on this platform. The results you'll work with should be familiar because you're working in a tabular format, which then you can query and join with other tables you might have to produce the end solution that you need. All of this is automated through job runs in Wherobots. So it's not the interactive environment with hands-on keyboard. That's typically how customers get started in like test out a solution. But then they also automate these solutions, this workflow using job runs as well. Okay, some key capabilities is we've developed a stack reader to just reference the stack collections and pull in the tiles that are required for inference. We have an open model catalog that we currently support a couple of models, but this is going to be expanding here soon. One of those models is the MetaSAM2 model, which I'll demo here shortly, and we're adding a number of models that are in the TorchGeo project. One of the key differences between like what we do and what you might find from SageMaker is that our inference engine scales. We're distributing inference across many nodes, GPUs. We also do CPU-based inference as well. If you want to run a CPU runtime, it's going to be lower cost than the GPU runtimes. And then, as I've said, you can join those results to drive the solution that that you're looking for. One of the key things, stepping back, what we're doing here is we're making these the power of these GeoVision models accessible to common developers. So you don't need to have a lot of expertise in model development or model training. Others can take care of that, load these models to our platform, and the developers who might be just familiar with SQL and Python can just consume those models and run them without having to worry about all of the other techniques and technology they may not be familiar with. All right, so we're very excited about TorchGeo. We are similar to Apache Sedona. We are investing in TorchGeo as a company as well. TorchGeo is a project that has a number of foundational models that are available off the shelf. Don't quote me on the exact number. Maybe Isaac can provide the number of models. I'll go through a few of them here in a minute. But what they are capable of doing is change detection. You can do field boundary delineation, et cetera, on these TorchGeo models. Here's a few of them. These will be supported directly in our model catalog. And today, if you wanted to, you can bring these in yourself, but we're working to pull these in directly so you can just deploy them in a single line of code. The MLM spec that I've talked about is really about making models portable across different engines, inference engines. Ryan has a session on this at 3 p.m., but this is one of the challenges that we saw in the model, across models, is that you can't just take models out of the box and deploy them on different engines. They're built specific for certain tasks, but also specific architectures as well. And so the MLM spec provides a vehicle for describing those models and how they should be ran so that they can be deployed on different inference solutions. So there's a link here in GitHub. You can check that out. Not sure how much time I have, but I would like to walk through. Oh, Siri's telling me how much time I have. I would like to walk through just quickly a quick demo of SAM2 and Wherobots. So very high level. What we did here is we took the scope of an airport. By the way, this demo is scoped pretty small because it's one of our demo notebooks that we're driving our customers to, and so it's more of an experimentation example. But prompted by we're prompting the SAM2 model with airplanes. The scope of data that we've imported into the inference engine is roughly the size of the Miami airport. And there was 2 tasks that were done, and I'll show you those here in a minute. One was segmentation, the other was bounding box application. The bounding box application is more suitable for like counting. If you're just looking for objects and you're counting those objects, for example. Costs about $1 and ran in less than 2 minutes. If I have some time, this is a demo notebook, and we do a lot of description of like what's happening and how to get started. But this is loading. We're loading data here, and this is this Miami Airport TIFF. We're tiling this out, and this is roughly the scope of the model's imagery input. Here you can see this. We've got a little Kepler viewer. Here's some sample tiles as well of the raw imagery. Now the model in this case, this was our SAM2 model. The prompt this is the text prompt, airplanes. This is a confidence threshold, so how confident that is the model and what it's generating. And then finally, here's the code that is running inference. It's pretty straightforward, and it's all done in SQL. That's kind of what I wanted to describe today from SAM2 perspective, but yeah, this is the same image that I showed you earlier, and then there's some more specific segmentation examples here. Okay, so we're expanding the model catalog. We're working with customers too to identify the types of models they want to run in Wherobots. There's some other challenges we're solving around the raster preparation to get it inference ready and also optimized through the inference engine. We're bringing MLM support to Torch Geo, and there's some other features that we're working on too. If you'd like to learn more, I'd be happy to talk to you in person. Okay, that's all I had. Any questions?
Great. That was a great presentation.
Thank you.
I have a quick question. Do you know where that Birds of a Feather is going to be at 3, the room?
I don't have my phone on me.
Okay.
Just
if anybody knows, maybe we can shout out. Any questions?
It's in Los Angeles.
Okay, so it's next door, because I think that's fascinating. I think one of the problems is models have become so specific. How do we make those more open? Right?
Yeah.
This is kind of a theme of the conference, how do we make things more open and accessible. I have a quick question though. We talk, and this may not, I don't know if you can answer it, but we talk a lot about satellite imagery and then we jump all the way to drones. What about this middle space of aerial imagery? Like people are investing tons of money in new aircraft, new sensors, and a lot of governments, a lot of insurance companies actually do flyovers after it. And I don't see any of them here. can you have any comment on that? Like, what about that middle space of raster imagery, geospatial imagery?
Yeah, I think we've talked about the satellite imagery because it's widely accessible and easy to, it's out there in the open. Whereas like the drone imagery is more privatized, and customers are keeping that in their own buckets, for example. And that can be, we can run inference on that as well. It's just we just integrate with the S3 bucket and start, running inference on that imagery rather than open data sets. So the same problems apply, and the same solution can be applied to that type of data as well.
Yeah. So like the aerial, because a lot of the aerial imagery that I know a lot of counties and governments, and sure, a lot of people, utilities fly, they get it, but they get it in a big bucket, right? They get it delivered that way. But putting it in the cloud and making that data more available seems like that would be a great next step for where this community maybe should reach out to.
I agree.
So, any questions come up? Okay, well, great. Thank you so much.